For question number 10 in section 3.1, we're asked to identify the vertex, the axis of symmetry, the y-intercept, the x-intercepts, and the opening of the parabola. Then finally sketch the graph. Now, this function is in the form of ax squared plus bx plus c. So to find the vertex, you want to find h, and h is equal to the negative b over 2a. And once you find h, get that value, you can use that to get k, where k is equal to f of h, which is found by taking the answer for h and plugging it back into the original function. Then finally, the vertex is taking those two values, hk, and writing them as an ordered pair. So, to um, to evaluate, oops, sorry about that. With the problem set up in this way, we can recognize that a is -1. Because that a is a negative number, we know it's a parabola that's going to open down, and b is equal to +2. So when we substitute those into the h, which is -b, or the opposite of 2, all over 2a, 2 times -1, we get +1. Now we're going to plug that into the original function for x. We want to find f of 1, which is -1 squared plus 2 times 1 minus 8. So it's a -1 plus 2, which is 1, minus 8 is -7. So our vertex is h, which is 1, comma, -7. Let's type that in. 1, -7 is the vertex. Now the axis of symmetry is that vertical line that goes right through the x value of the vertex. And that is going to be x equals 1. Let me write that down. Okay, the axis of symmetry is always that vertical line that goes right through the vertex. It's going to be x equals 1. So again, imagine you have this parabola where the graph is a parabola that opens down. The coordinates of the vertex are 1, -7. 1, 2, 3, 4, 5, 6, 7. This is your vertex, and it's a parabola that opens down. So it's going to be something like this. That axis of symmetry is the vertical line that goes right through the vertex, and that's happening at 1. Now to find the y-intercept, okay, the y-intercept is found by setting x equal to 0. And let x equal 0, and you plug that into the original function. F of 0 is equal to, you plug that in for x, you get -0 squared plus 2 times 0 minus 8, you get -8. That's going to be your y-intercept. That's where the graph is going to cross through the y-axis, way down here at -8. Now, we're asked the question, how many x-intercepts does this parabola have? If you already have an idea where the vertex is and the y-intercept, and you know that this parabola opens down, you can tell by looking at the graph that it's not going to cross through the x-axis. It has no x-intercepts. And also we're asked, which way does the parabola open? Well, because the a is a negative, we can say that this is a parabola that opens down. We want to select the graph that shows a parabola with a vertex. It looks like the third option here, the vertex of 1, -7, and 1 -8. Now look at the scale here, it goes from -15 to +15. So that looks about right. Looks about like -7 and -8. I'm going to make that choice and check the answer. Now this last question in section 3.1, number 11, it's the rocket problem. It is rather lengthy. There's a lot of things that are being asked, but do take the time to go through and really understand this one, because I may ask you a question like this on the test. Now, it may not be a 4-part question on the test, but it could be just maybe part A, give the function that gives the height, or part B, uh, when does it reach the maximum height, and what is the maximum height? So you can still expect to see something similar to this on the test, but perhaps not as many steps. Now, part A is, first of all, let me say that the toy rocket, imagine a toy rocket is launched from the top of a building that's 50 feet tall with an initial velocity of 175 feet per second. Give the function that describes the height of the rocket in terms of time, t. Now I have listed on the instructor hints the height equation that we use. We use s of t to denote the height. The height after a certain number of seconds t is equal to -16 t squared plus v sub 0 t plus h sub 0. Now what that t represents is time, and the v sub 0 is your initial velocity, and h sub 0 is your initial height. So we can determine the initial velocity and the initial height based on the information that's given at the beginning of the problem. Since we see here, we have 50 feet and 175. Those are two values that we're going to plug in to the height equation. Now, if the building is 50 feet tall and you're launching the rocket from 50 feet high in the air, that's going to be your initial height. H sub 0 is equal to 50. And it says specifically initial velocity is 175, so that's your V sub 0 is 175. By plugging those in to S of t, we get our function that gives us the height of the rocket in terms of time. So we replace that initial velocity with 175, use the t, and then the initial height for my example is 50. This is the answer for part A. That's what they're looking for. This, you should recognize that it's a parabola. It is a parabola that's going to open down. And just imagine, without even evaluating this, just imagine that you have a rocket that you're launching from the top of a 50-foot tall building. Imagine that rocket's going to go up, and then it's going to eventually come back to the ground. This equation models that time. As time increases, the horizontal axis is time, the vertical axis is your height. So as time increases, the rocket's going to go up, and then it's going to eventually come back and hit the ground. So that's our model equation that we use. So it's asking for -16 t squared plus 175t plus 50. Now part B is asking us about the maximum height. The rocket reaches its maximum height at blank feet after blank seconds. Well, imagine, if you have an idea of what this graph looks like, this goes up and it comes back down. That maximum height is going to be where the vertex of the parabola is. That's key in solving part B. Okay, so to determine where that maximum height is, you want to find the vertex of the parabola that's represented by this height function. If we could figure out this point right here, that's going to give us the time where it's at its highest point, as well as the maximum height. So you remember how to find the vertex. The vertex is in the form of h comma k, where h is equal to negative b divided by 2a, and b is 175, so that's going to be the opposite of 175, all divided by 2 times negative 16. So that's negative 175 divided by negative 32. Do the calculation to get 5.6875, and I'm going to write that as, let's see, it says round to the nearest tenth, so that means it's 5.47 is the h. And then the k we find by plugging that back into the original function. Now you want to be careful when you make that substitution because you don't want any rounding errors. So rather than put in the decimal rounded answer, I'm going to plug in the fraction, 175 over 32 plus 175 times 175 over 32 plus 50. Okay, so I'm going to use a calculator just to find that value. And I got rounded. If I round this answer, I get the k is 528.5. Okay, and this would be 5.5 if we round it. So at 5.5 seconds, the maximum height reached is 528.5. Okay, so what this means is the maximum height is 528.5 feet, and this is after 5.5 seconds. Check your answer. Alright, so again, the key to finding part B is to locate the vertex, and that vertex is going to give you a time and a maximum height. For part C, we're asked, for what time interval will the rocket be more than 507 feet above ground level? Okay, for this one we want to find out when will the rocket be more than 507 feet above ground level. Now we know that the rocket starts out about 50 feet above ground level, and then it goes up, it's going to come back down. We want to find the time when it's over. It actually goes up to 528 feet, so we want to locate the time when it is above 507 feet. That's going to be somewhere along this line. Just kind of draw a dotted vertical horizontal line here. There are 2 points in time where the rocket is above 507 feet, between those two values. And we know that it reaches its highest point from the previous answer at about 5.5 seconds. So it's got to be somewhere between something a little less than 5 seconds, a little more than 5 seconds, so somewhere in between these. Now the way you can do this algebraically is set the whole height equation, find out where it's equal to 507. So if you set S of t equal to 507, and you get negative 16t squared plus 175t plus 50 equals 507. Now what you can do is use a quadratic formula to solve this, but you do need to get one side equal to 0. So if I subtract 507 from both sides, I get negative 16t squared plus 175t plus, give me a second here, 50 minus 507. So that's going to be minus 457 equals 0. Now, by using the quadratic formula, I'm not going to get into it here, but take the time to use the quadratic formula where A equals negative 16, B equals 175, and C equals 457. You'll get two values for t. Those two values for t are going to be 4.3 and 6.6. So those are the two time intervals where the rocket is higher than 507 feet. So the interval is going to be everything in between those. So we can write it as 4.3 to 6.6. You can take a look at my notes with solutions to see an example just like this where I've actually used the quadratic formula and worked it out. But we've practiced using the quadratic formula quite a bit before you get to this step, so that's why I chose to omit it. Now, let's look at the next question. I believe it's the last part. After how many seconds will it hit the ground? Well, you think of this as a graphically what's happening here. You have this rocket goes up and then it eventually comes back down. Where it actually comes back down and hits the ground, that's your x-intercept. And you find x-intercepts by setting the y equal to 0, or in other words, the height equals 0 when it hits the ground. So if you set the whole s of t equation equal to 0, that's going to help you find the time where the object hits the ground. So if you set the whole equation to be equal to 0. Now this is something you can use a quadratic formula to find. The quadratic formula, here we have, with the quadratic formula, A is equal to negative 16, B is equal to 175, and C is equal to 50. Remember the quadratic formula is x equals negative b, opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. Plug in those values. It's going to be the opposite of 175 plus or minus 175 squared minus 4 times negative 16 times 50, all divided by 2 times a. Okay, I'm going to use a calculator to simplify this. I'm going to do the part under the radical, 175 b squared minus 4ac, 4 times negative 16 times 50. That's the square root of 33,825, all divided by negative 32. Now use a calculator to find this once with a plus sign. If I do the plus, so when you evaluate this quadratic formula, where you do the negative 175 plus the square root, and you simplify that, the answer that you get is negative 0.278, or about negative 0.3. When you do this with the minus, you get the negative 175 minus the square root over negative 32, you get 11.2. Now, x in this case is really time. So even though the quadratic formula gives us two answers here, think about this in terms of what makes sense. Does the rocket hit the ground at negative 0.3 seconds, or does the rocket hit the ground at 11.2 seconds? Okay, well, it would make sense that the rocket would hit the ground after 11.2 seconds rather than a negative. It doesn't even make sense. So let's go ahead and check our answer. Okay, sorry if I didn't round it correctly. It does say to the nearest hundredth, so that answer should be 11.22. 11.22. So let's try that one. I was trying to rush through this. And that's it. So even though this problem is rather involved, it does have everything to do with a basic quadratic function. You want to find the vertex to determine its maximum height, and you want to find out where it's equal, where the height is above 507 feet. You want to set it equal to 507 and use the quadratic formula to get the two time values where the rocket is actually above those. And then for the last part, it hits the ground. When you set the whole equation equal to 0 and solve it, you can determine the time where that rocket hits the ground and choose the one that makes sense.